Hello, welcome back to 201 Math. I'm your host Jaime, and today's topic is factoring by grouping. What is factoring by grouping? It's a relatively simple process that involves expanding the b term in trinomials into two parts so that a greatest common factor can be taken out, or factorized. How do we split the b term into two parts? So basically, you need to find a pair of numbers that, when multiplied together, they equal what the coefficient of c is. This pair of numbers must also add up to the coefficient value of b as well. So what do I mean by that? You have ax squared plus bx plus c, where a, b, and c are coefficients. So let's just say that p and q are a pair of numbers. So when p and q are multiplied together, that equals to c. And when p and q are added together, they're equals to b. So you have ax squared, and then you expand this to have qx plus, px plus qx rather, and then that's what you have. And then you split this into two parts, and then you take out the greatest common factor of these two groups. So let's do some example problems. So our first example, we have x squared plus 6x plus 8. An easy way to find a proper pair of numbers for b that add up to b and multiply to c is to list out all of the factors of c. So you have 1 and 8, 2 and 4, and that's it. So clearly we see that 1 and 8 add up to 9, so that can't be it. But 2 and 4, that adds up to 6. So this is our pair of numbers. And now we have to expand the b term. So we have x squared plus 2x plus 4x plus 8. So now that we've expanded the b term and we have 4 terms, we could group these two sections together. So the first two terms will be one group, and these two terms will be one group. Keep in mind that this is not an absolute value sign, it's just a way to denote or just easily separate the two groups. So what's the greatest common factor for x squared plus 2x? That's just going to be x. So you have x factored out is x plus 2. And then what's the common factor for 4x plus 8? You just have 4, which is also x plus 2. So a vital step in the grouping process is to make sure that once you factored out the greatest common factor, the remaining term is equal to each other on both sides. So we have x plus 2 here and x plus 2 here. So we could just write x plus 2 here. And these remaining numbers, they can also be added to a group. So x plus 4. And that's our final answer. That's just how we factor by grouping. Very simple process. We could FOIL to make sure this is the correct answer. So first, we have x squared outer plus 2x inner plus 4x plus last, which is 8. And we have this over here, so I don't need to even simplify that. So that's the first example. That is done. Now I'll move on to a different example, another one that's relatively easy. So now we have x squared plus 5x plus 6. Once again, let's list out the possible factors for 6. So we have 1 and 6 and 2 and 3. 1 plus 6 is equals to 7, so that can't be it. But 2 plus 3 is equals to 5, so that could be it. So now we very simply just expand the b term once again. So we have x squared plus 2x plus 3x plus 6. Let's split that down the middle once again. Now we take out the greatest common factor on both sides. So the greatest common factor of x squared plus 2x is equals to x times x plus 2. And the greatest common factor of 3x plus 6 is just 3. So we factor that out as well. We have 3 times x plus 2. Once again, we see that the remaining terms is equals to x plus 2. So we're on the right track. So just leave that over here. The remaining two numbers, which are x plus 3, we could just group that as well. So we have x plus 3. I meant to write x plus 2 over here. I apologize. So that is our final factored form for x squared plus 5x plus 6. We could FOIL once again to verify our answer. So let's just do that real quick. X times x is just x squared. X plus 2. The product of that is just 2x. 3 and x. The product of that is just 3x. And 3 and 2, that's just 6. Because we have that over here, we don't need to simplify any further because we know we have the right answer. So now I'm going to demonstrate a non-trinomial being factored by grouping, which I'd argue is even easier because we don't need to find the common terms. So you can use factoring by grouping even if the expression isn't a trinomial. When there are 4 terms in descending degrees going left to right, and if a greatest common factor factorization is possible on both sides, then you could factor by grouping. So what's an example problem that demonstrates this? We have 5x to the third plus 25x to the second plus 2x plus 10. So let's split that down the middle just like we've been doing with the trinomials. And we can see that the greatest common factor here is just 5x squared. So let's take that out. Let's factor that out. And then we are left with x here plus 5. So that's our first group done. And then here the greatest common factor is just 2, so we could factor 2 out. We are also left with x plus 5. Because these are the same over here, we could set that as one of the terms. And the remaining terms are 5x squared plus 2, so we could just do that, 5x squared plus 2. And that is our final factor form. Once again, we always want to verify by the FOIL method to see if these are truly the factors. So we have first, which is equals to 5x to the third. Outer, which is equals to 25x to the second. And then we have 2 times x, which is just 2x. And then we have 2 and 5, which is just equals to 10. And that's our final answer. We could see that this is the correct factored form. So in summary, we could easily factor most trinomial expressions using the grouping method. And even if it isn't a trinomial, if you have descending terms going left and right, and if a GCF factorization is possible, where you're left with the same terms, then you could factor by grouping even if it is 4 terms. So thank you for watching, guys.